All right, so we're talking about matrices, in this specific topic is how to find, we want to talk about how to find the inverse of a 3 by 3 matrix. We are going to do it one way this week, and then next week we'll show you how to do this same thing in a different way using mastery level techniques. Let's take a look. All right, so we got, let's call it matrix A. We call this matrix A, and this matrix A, let's say, is this first row is 1, -1, 2, 0, 1, 4, -2, 2, -3. All right, so that is our matrix, and we want to find the inverse of this matrix. And there are a lot of advantages, a lot of reasons why you'd want to find an inverse. A lot of it has to do with higher level mathematics, but for now let's just go through this process of finding the inverse. All right, so we want to find the inverse, or A sub -1. All right, so the way we do this is to establish what we call an identity matrix, where this main diagonal are all ones, everything else is a 0. This is called an identity matrix. And the goal, this technique that we're going to show you for today, and a different technique next week, this idea of having an identity matrix on the right, our goal will be to transform this initial matrix to the identity matrix using a variety of different manipulations. And then the result of this right side will end up being our inverse. So unless you have a background in matrices, that might not be entirely clear, but hopefully as we're going through this process, it'll be clear what I am saying. We want to transform this left matrix to look like the identity matrix. And as we are transforming this to look like this right side will be adjusted through the process. And the result, after this becomes the identity matrix, the result of this will end up being our inverse function. Let's stop talking about it and let's do it. All right, so notice how, and by the way, another thing we're going to do is we're going to take this approach where we address the numbers sort of, I don't know, this L shape here. We're going to attack the 1, 0, -2, go in that direction there. All right, so notice how this first number is a 1, and so is that. So we're not going to really attack this 1 here because it's already the number that we want. Similar, there's a 0 here, there's a 0 here, so we're not going to attack these first two numbers here. And again, I'm going in a downward direction. But here, this -2, we want to address that because we want it to be a 0. All right, so what we're going to do is we're going to manipulate this matrix a little bit, and you get more and more comfortable with this the more matrices you work with. We're going to take this top row, 1, -1, and 2, and multiply it by 2. Add it to this row, and that would give you the 0 that we desire. So let's go about doing that. I'll go off to the side here. If we multiply this top row, this entire top row, by 2, we get, okay, so we're going to take 2 times row 1 and add it to row 2. I think it'd be clear if I wrote that out. All right, so 2 times row 1, that would be a 2, -2, 4, multiplying this whole row by 2, 2, 0, 0. And I'm adding that to, I think I wrote row 2, I meant to say row 3, sorry about that. Row 3. I'm adding it to row 3. So here I have -2, 2, -3, 0, 0, 1. I'm going to add those together and that's going to be my new row 3. All right. So if I do that, let's rewrite the first row here. So we've got 1, -1, 2. I'm rewriting the first row. 1, 0, 0. And the second row, I'm going to leave that the same because we were satisfied with these two numbers. 0, 1, 4, 0, 1, 0. All right. And now I'm going to add these two rows together and get the desired 0 here that we wanted in this position right there. So we add 2 and -2, we got 0. We added -2 and 2, we get 0 again. We add 4 to -3, we get 1. 2 to 0, we get 2. 0 to 0, we get 0. And 0 and 1, we get 1. All right, so that one step really took care of a lot for us. All right, so it really took care of not only this, not only the 0 here, but we have a 0 here, which is what we wanted, and we have a 1 here, which is what we wanted. So really, we got this triangular piece all set. We got that triangular piece all set. So now, what we want to do is we want to attack maybe this 4 here. Let's attack that 4 here. So a couple directions we could go in, but let's try to make that a 0. Okay, again, we want this 4 is in this position here, and if we could make that a 0, we'd accomplish our goal of trying to make this side here the identity matrix. All right, so let's try to multiply. Let's multiply this bottom row here by 4 and subtract it from this row here. And again, if we multiply this row by 4, this will become a 4, and we would subtract to get the 0 that we want here. All right, so let's take row 2. Let's take row 2, leave that alone. Let's subtract 4 times row 3. All right, row 2, subtract 4 times row 3. All right, so row 2, that's 0, 1, 4, 0, 1, 0. And then we got 4 times row 3, that would be a 0. That would be a 0. Multiply this by 4, that would be a 4. Multiply this by 4, that would be an 8. Multiply this by 4, that would be 0. Multiply this by 4, that would be 4. All right. All right, and that's going to be our new row 2. All right, so let's keep the first row the same. We've got 1, -1, 2, 1, 0, 0. Let's subtract these, and that's going to be our new row 2. So we get 0, 1. Subtract these, we get the 0. That's why we did this manipulation in the first place. Subtract those, you get -8. Subtract here, you get 1. And subtract here, you get -4. And let's keep our third row the same. So we get 0, 0, 1, 2, 0, 1. All right. All right. So we're a step closer to getting this identity matrix. We've got all of these numbers in place. We've got these numbers the way we want them. Let's try to attack this number right here. Let's try to attack this number right here. All right, so we want this to be a 0. We want this to be a 0. When you have your identity matrix, the number that you have in this upper right hand corner is a 0, and we want that to be a 0. All right, so what are we going to do? Well, let's take equation 3, multiply that by a number that would allow this position to be 0. Hopefully you see that if we multiply by 2, this would become a 2 and we could subtract and get 0 there. So let's take row 1, subtract 2 times row 3. Take row 1, subtract 2 times row 3, and we'd get 0 in this position right here. All right, so we got row 1, which is 1, negative 1, 2, 1, 0, 0. 2 times row 3, that would be 0, 0, 2. Multiply this by 2, we get 4. Multiply this by 2, you get 0. Multiply this by 2, you get 2. And that's going to be our new row 1. All right, so we're going to subtract there. We get 1. We wanted 1 in that position. We subtract here, you get negative 1. So we're going to have to attack that. We don't want negative 1 there. And subtract here, you get 0. That's why we did this transformation in the first place. Subtract here, you get negative 3. Subtract here, you get 0. Subtract here, you get negative 2. All right. So now let us write the second row and the third row as it is, because we're satisfied with that. 0, 1, 0, negative 8, 1, negative 4. And this row is 0, 0, 1, 2, 0, 1. All right. So we are just about done. We are just about done. You might observe that this process is somewhat tedious. This is normal. This is normal. All right, so the last number that we have to attack is this number here. We want that to be a 0. And the last step here would be to just add these matrices up, because notice how if you add here, you get 1. You add here, you get 0. And that's what we want. You add here, you get the 0, and that's going to be our new first row. So let's take row 1. Let's just add it to row 2. The whole key to this whole process is to try to get this identity matrix. This is the identity matrix. We're trying to get that over here. Everything we've been doing is an attempt to get this left side to look like the identity matrix, and we're almost there. We're attacking this last number right here. All right, so let's do that. Let's do that. So if we add row 1 to row 2, that's going to be our new first row. If we add row 1 to row 2, we get 1, 0, 0, negative 11, 1, I'm adding up first row to the second row, negative 6. All right. And then our middle row, we're going to keep that the same, 0, 1, 0, negative 8, 1, negative 4. And then we have 0, 0, keeping the third row the same, 1, 2, 0, 1. All right, and notice how we've got the identity matrix. So our inverse of this 3 by 3 matrix is this right side here. Negative 11, 1, negative 6, negative 8, 1, negative 4, 2, 0, 1. Okay? And that is your answer. Now, a lot of times what you can do is you can take this negative 11, 1, negative 6, negative 8, 1, negative 4, 2, 0, 1, And if I did not put this in the wrong order, what you can do is you can multiply that by your original problem. 1, -1, 2, 0, 1, 4, -2, 2, -3, and you should be able to get the same thing. You should be able to get the same thing. Let's try to do that. To multiply these matrices together, you want to multiply the first row in the first column. So you would do that right here. The first row is this row with the -11. First column is this column here. So you have -11. 1 times 0 is 0 plus 0. And then -6 times -2 is +12. And notice how you get a 1. See, when you multiply the inverse by this original matrix, you should get the identity matrix. You should get the identity matrix. All right. So then the first row with the second column, you'd want to multiply this row to this column. All right. So you'd get 11. You get 11 plus 1, and then -6 times 2 is -12, and you get 12 minus 12, which is 0. So it's really working out. See, anytime you have an original, let's say you have 2 times reciprocal of 2, you're going to get 1. If you have 1/3, you multiply by the reciprocal of 1/3, you get 1. A matrix doesn't have a reciprocal, a matrix has an inverse. So if we're multiplying this original matrix times its inverse, we should get 1. Not 1, the number 1, but the identity matrix 1. And it's really beginning to work out. I don't know if we'll have time to get the rest of the seven terms of the matrix, 7 elements of the matrix, but let's just keep going. We take the first row in the third column. This row, this column. We get -11 times 2, that's -22. 1 times 4, which is +4. And -6 times a -3 plus 18. And you get 0, which is what we expected. It's what we expected. Let's just keep going as far as we can because we're running short on time. So let's take the second row, first column. All right, so we got the second row, first column. That would be -8, -8 plus 0, and +8. Notice how you get 0, which is what we expected. We only have time for one more, but it's really working out just the way we want it. All right, so let's take the second row, second column. This second row, let's multiply it to that second column. So we get 8. -8 times a -1 is 8, plus 1. And then -4 times a +2, we get a -8. And you get the 1. So everything that we expected is really working out. This position, this is where we left off last week. So what we're going to do is we're going to multiply this row times this column. So we get -16. You get -16 plus 4. And then -16 plus 4 plus 12. Plus 12. So you end up with -16 plus 16, which is 0. All right. So then we're just checking to make sure that this inverse matrix is correct. So now to get this part of your matrix, you're going to take this row times this column. So you have 2 plus 0 and minus 2. So you get 2 minus 2, that's 0. To get this part of your matrix, that's the third row, second column. Take the third row, second column, you get negative 2 plus 0, negative 2 plus 0. Uh-oh, sorry about that. Negative 2 plus 0. All right. So you're taking the third row, second column, negative 2 plus 0 plus 2. You get 0 again. And now, this is the third row, third column. Let's take the third row, third column. We got 2 times 2, which is 4. Plus 0. And then minus 3. So you get 1. So notice how you get that identity matrix, which in terms of a matrix is 1. This is 1. So you, in the same way that we took a number multiplied by a reciprocal, you get 1. You multiply a number by its reciprocal, you get 1. I took this matrix, multiplied it by the inverse of this matrix, and we got 1 in terms of matrices. That is a way of checking your work. That is a way of checking your work, which indicates that this is correct. This was indeed the inverse.